and welcome back to another episode of Hollywood Physicists with your favorite hosts, Rebecca Navarre
and Kaylee Raymond,
where we break down some of your favorite action scenes and help you see,
is this possible?
Looking at the physics of some movies and shows, you may begin to question whether these things could really happen. Tune in next week to watch a debate on whether SpongeBob could really breathe underwater. Right now, we're going to break down a popular action scene from one of the Fast and Furious movies. In this scene, you'll see a car jump off of a cliff and onto a boat. I mean, I'll admit, the scene looks pretty cool. But is it realistic? Now here we see the car accelerate to about 120 miles per hour, or for the sake of physics, about 53.64 meters per second, before it launches off the cliff and ends up landing and crashing onto the boat. This car is a 1969 Chevy Camaro, and we know that this car is able to reach speeds even beyond this. Because of the agility and speed of this pretty cool car, we know that this much is realistic.
Since we see that there is a curve in the road, this allows the car to accelerate while the boat slows down and the car is able to get behind it. Because the boat had to turn, this seems reasonable that the car would end up behind the boat. The boat was required to slow down so it could go through the turn. Now let's take a look at this jump scene again.
We can see here that the car appears to leave the cliff on the incline plane, which seems to be at about a 30-degree angle, give or take some. We can't really see the point that the car leaves the cliff in this scene, so we must assume that this is true in order to estimate the distance between the cliff and the boat.
We must estimate the distance in order to find out whether this seems to be a reasonable jump for this car to even go through. Now let's head to the lab and figure this out.
Now let's take a look at this equation. As seen here, the distance is equivalent to the velocity initial of the car squared times sine 2 theta. The theta is equivalent to the inclined plane that the degree of the angle is about 30 degrees, over 9.8, which is the acceleration due to gravity. As seen here, 53.64 is 120 miles per hour in the form of meters per second. So they are equivalent. So we square this and then we multiply it by sine of 60. The reason that it's 60 is because we have to take 2 times theta, which is 30 degrees, over 9.8. And so what we find is that the distance between the car and the boat should be approximately 254.3 meters.
Due to our very small budget and not being able to find any yachts or Camaros on Amazon or Craigslist, we only had 2 other options.
The first option was to put our information onto some pretty sketchy websites. They wanted our social security numbers and some other pretty personal information, so we decided to go with option B, where we use a toy car and a toy boat to act out this scene instead. And we're aware this isn't very accurate compared to a real car or boat, but it's the best we're going to get.
Due to some technical difficulties, again, we were not able to film this jump scene correctly. Our last resort was to have our fellow colleague film the jump scene at his cabin. We understand this is not completely accurate, but you get the idea.
When we timed the scene, we can see that the jump appeared to only last about 13 seconds. Now this could be very accurate, but it's always good to double check.
The time is important because we can see how this movie may have altered the scene just for the sake of entertainment. For this to really happen, it's actually quite possible that the scene could have occurred in 13 seconds.
Since the movie directors most likely either cut or added to this scene, and there's a cut frame, we can also assume that this jump was reasonable and was simply either skipped around a bit or added to. Another thing we must account for is human error. When we filmed the scene, we may have missed a part or started it too early. So let's take a look at this equation in the lab to see how close it really was.
In this equation, t equals 2vy divided by 9.8, we are going to find the time that it takes the car to jump. 53.64 meters per second is equivalent to 120 miles per hour. We multiply that number by 2 and divide that by 9.8, which is why we get 10.95 seconds, which is pretty close to when we timed the actual scene, which was about 13 seconds.
So yeah, this scene from Too Fast, Too Furious is kind of realistic, if a few things about the movie were altered. For the sake of Hollywood, sometimes the rules of physics are not always followed. In this case, they weren't too far off.
Tune in next time as we discuss whether Dora can actually have a talking map.
Now remember, your favorite movie scene or TV show may actually be very wrong in the realm of physics.
Thanks for watching!
This scene looks pretty cool, but is it realistic? Let's watch the scene.
I'm sorry. 1969 Chevy Camaro, and we know that this type of car is able to reach speeds higher than one. I cannot talk. The car. Yeah, we should. The car is a 1969 Chevy Camaro, and we know that this car is able to reach speeds much higher than 120. I almost said 127. For the sake of physics, we're going to say that that equals to be about 50. Since the boat has to turn because of the curve.
But as we see here, we have to double the theta because it's doubled. That sounded really stupid.
Due to our very small budget and not being able to find any cars or yachts on Amazon or Craigslist,
So we must assume that this is true in order to truly estimate the distance between the car and the cliff the very best that we can. I said car and cliff. Can't really see the point that the car leaves the cliff all the way to the boat in the jump air. What is a jump air?
I don't know. Tune in next week and we'll figure out what a jump air is.